Today we are starting off with our very important introduction to audio-visual digitization. And specifically, once again, I'm going to be covering best practices. And this is in order to set you guys up so that you understand a lot of the basics for what we have created the Memory Lab to do, and which is not necessarily best practices, but on the spectrum between worst practices and best, and definitely better than good practices. So I think it's best to start with audio and then we move into video. But when I say audio visual, I'm talking about both. So we're gonna lay the groundwork with audio digitization, and then we're gonna start digging into the slightly more difficult video digitization. Okay. And can I just ask, can you guys see the full screen of my slides, or is the chat box like in the way? I want to make sure that you can see everything. It might not be. Okay, all right. It's just my view. Okay, so great. So this is one of my favorite Latin phrases. I took Latin in high school. Audio, video, disco, and audio means I hear, video means I see, and disco, fun fact that you can pull out at parties, means I learn. So today we're focusing on audio, and which obviously has to deal with sound recordings and sound and signals, audio signals. So this is a waveform, an audio signal waveform, and this is just like a very easy slide that I can show you guys to illustrate that what sound is. All sounds are vibrations traveling through the air as sound waves. When these changes in air pressure vibrate within your eardrum, then nerve signals are sent to your brain and it's interpreted as sounds, so those vibrations. The same concept is what happens in a speaker or a sound system. So basically like the speaker acts as an eardrum, and vibrations are how you hear and how the sound is broadcast. Sounds can be broken down into a combination of these waves. So this is you know, these waveform sine waves. It's a good way to visualize something that you can't see, and it's a good way to visualize an audio signal. There are so many formats that you can record these sound waves onto. Sorry about that. So there are so many formats that you guys can record these sounds onto, and these sound waves onto. I'm showing you just like 3 of like many, probably hundreds, maybe 100. So these are ones that you're not necessarily gonna see in your Memory Lab. Hopefully you won't see a wax cylinder or a wire recording. Maybe someone will bring in their 8-track tapes and hope for digitization, but there's not typically a lot of unique stuff recorded on there, so that's not something I recommend that you add to your Memory Lab, but I bet people will try and donate their 8-track players to you, which is fine if you want to have one. A lot of them are really cute and pretty if you like old retro stuff. So I'm just, you know, this point is just that there are so many formats out there that I even have been doing this for 10 years and specialize in AV preservation, and I see formats every year that are new to me. So it's okay that if you come across something you don't know what it is. And today we are focusing on sounds that are recorded onto magnetic tape. What I would do if we were in person, and what we'll do at boot camp, is I'll pass around a piece of film, motion picture film, which I do luckily have one here. So here's some film, and you can see sort of through, like you hold it up to light and you can see through it. So this is, and if there were an image recorded onto this, you can see a little bit of meter up there. Basically, like you can usually see like, oh, that's people. And if you put it on a light box and have a little magnifying glass or loop, you can basically see what's on there. You can see if there's a soundtrack. Like there's a lot of information that you can see just by holding it up. Video and audio, on the other hand, is very different, right? So here let's use a VHS because that is what you guys are going to be working with. So here I have my VHS tape, and you know, you hold this up. There's the tape, the shiny part, and that's where the information is on the outside when you open up this lid. So that's where that info is, and the signals are recorded onto, but you can't see anything. You can't see them. You can't understand exactly like what is on there, if it's people, if it's, you know, an oral history, if it's blank, all kinds of stuff. It's just a mystery with magnetic tape. So this is an obligatory diagram of what like a magnetic tape close up, super close up, looks like and what it consists of when you really get down to the minute particles, just so that you can understand. And there's literally like no other diagram out there. So this is something that you will regularly see. And I just love how like low resolution it is. And the lubricant like reservoir looks like a banana peel. So this is all we got. This is the best we got. But I kind of love it. Maybe I'll make t-shirts and put this on that for everyone. So you have your magnetic particles. That's that part that I was showing that you see nothing. That's the magnetic particles are where the information and where the signals, those audio signals, because we're talking about audio, is stored. Okay, so then on the other side, that's your back coat, and you know, that's where there's no information stored on that side. So if you accidentally touch that side, it's less of a big deal. But it's basically on one side is where all the information is, because that's what gets read in the playback decks. And the other aspects of this, we'll talk a bit more about. Like a binder is basically what holds all the magnetic particles and lubricants and things like that together onto the plastic substrate and back coat, or onto the plastic substrate and then the back coat and the lubricant are all meant and made so that the tape moves smoothly through a lot of moving parts, which you will see in person. We'll open up decks and things like that, and you'll see the tape move through it and see all the different moving parts that the tape has to touch. So it's really important that it moves smoothly through that to get proper playback. So all of these things that you can't see on a magnetic tape are, you know, it's all there. So there's a lot going on a really small granular level that you can't see with magnetic tape. And that's both audio and video. So we'll talk more about magnetic tape with our video. So here we have our, basically this can get confusing really quickly. And I wanna give you guys this information, but if it's a little confusing, I wouldn't harp on this too much because it's not something that you'll necessarily need for the memory lab. But there is a difference between mono and stereo audio. So, and then like channels versus tracks. So I think perhaps everyone remembers cassette tapes, which I think I have mine stored below. You know, your regular compact cassette tapes that you would have to turn over, right? You'd have to flip over. You have your side A and your side B. Oh, I have my little zine, my mixtape zine. So you can see my drawing that I had to Google how to draw that on the internet. So you have your cassette tape and you have to flip it over A and B. And it's still the same reel of tape inside, right? So when you're flipping it over, it's this diagram here is kind of explaining that. So where you have your, basically mono means one channel of audio, and that was before they figured out how to have two channels of audio, which is stereo, which is more like how we sound, or how we listen, which we have a left and a right ear, right? That's how we hear sound more. So when you have stereo audio, you have two channels. One is left and one is right, and they can be slightly different, but it just gives you better sound quality than having the one mono channel that you just hear the same thing out of like both sides of either your speakers or your I was gonna say earbuds. Yeah, earbuds. So mono, you can see mono at the top, and then stereo. So for example, if you had a stereo, so the dark, the black boxes are indicative of what sound is on. So if you have a full, or an audio signal is recorded onto, so if you have a full track mono audio tape, basically means that along that audio tape there is just one channel of sound. So it's just the same thing. It would sound the same out of all sides of your earbuds or your speakers, and it's all the way stored all the way across the tape. And then you wouldn't be able to like flip it over and play anything, okay? But if you have a mono half track, that is still one channel, right? One channel of audio, but half of the tape basically is, there is one mono channel recorded, and then you flip over and then you can listen to another mono channel. If you have a 2-track stereo recording, then you have stereo, so you have your left and your right when you're listening to it, stereo recording being recorded onto the tape, and then you flip it over and, sorry, that one you can't flip over, but it's basically that that top one is your left and the bottom one is your right. So, and it's just one playing over. But then the next 4-track is basically you have your left and your right, and then you flip over, and that the little white squares would be your flipped over audio. So of your left and your right signal. So I know that this, I don't know why I like really feel like I want to teach this when I'm doing audio, but I think because we a lot of times hear the words tracks and channels used interchangeably, and it's not really the same thing. So that's basically the gist of what I'm trying to get across with this. And it's okay if you don't quite get it. I definitely didn't get it when I first saw this diagram in grad school. So I can always, talk more about this later if you want to understand it. But once again, it's not really that important. Just know that you'll be focusing more on understanding the difference and interacting with media that has mono or stereo. It's better to have all your playback equipment be stereo, because then you can do either mono or stereo. If you just have a mono playback deck, you can't do stereo as well. So that's really how you'll have to like think about stereo of left and right, but don't use the word tracks interchangeably with channels, because then you'll start confusing, you could be confusing people, especially if you're dealing with a vendor, an audiovisual preservation vendor, or something like that. So why are we talking about magnetic tape so much? And because it's extremely at risk. And this is something I really need you guys to get across to your communities. And I think you all understand this, but I literally will use any chance and platform I get to reiterate that it's the final countdown. Magnetic tape is extremely at risk, and we only have until approximately 2028, which now it's 2020, can't believe that, until catastrophic loss of legacy magnetic tapes come about due to this term called degralescence. And degralescence was coined by Mike Casey at University of Indiana, Bloomington. it is a mix of two words, and that is degradation and obsolescence. So it's degradation of the physical tape itself, and like that, you know, and the binder and the particles, and all magnetic particles and all that, lubricants that you saw in that diagram. So that degrades, but then also the equipment that is needed to view those, because you can't just hold it up to light, the equipment that you need to play those back and to digitize those tapes become obsolete. So there's your obsolescence. It's the obsolescence of the equipment and the formats. And then it's also obsolescence of this expertise that's needed to maintain the equipment, to keep it up in working order, and also the parts that you'll need to keep your equipment in working order, because those are no longer manufactured and people are no longer taught how to fix them. Please reuse this slide. I'm very proud of it. So when we're talking about audio, the main thing, as I mentioned, that you'll see in your memory lab is these compact cassettes. And, you know, we're gonna go, I like to go a little bit more granularly into this. Our data has shown that it's actually not super popular. It gets used, it definitely does get used, but it's not as popular as VHS, which we'll talk about, and which is why we're going to be really focusing on VHS when you guys are here. And I really want to make sure that you guys get that down. But audio is easier. Audio is just easier than video. So it's a good way to start. And also, while we can't promise you guys to buy you a compact cassette deck, I bet you'll get a lot of, because it's around $500 right now. And we really need to focus on the scanner and the VHS setup. So if we do have leftover money, we'd love to buy you that nice compact cassette deck. But I bet that when you put a call out to your communities, that people will respond with their old cassette players. And you all might have, maybe if you guys want to respond in the group chat, how many of you guys have maybe internal collections, maybe some oral histories that are recorded on compact cassettes, because it's been around since 1964. And it's, I mean, my neighbor, who is much younger than me, recently put out his album on compact cassette and is selling them locally. So it's still a pretty popular format. And while you can, you know, get commercial music quite often on it, and, you know, that you would purchase, you'll also find lots of different content. So starting from the 1960s, you know, oral histories and dictations, lectures, events, live performances. This was a cheap and super like compact format. So it really gave people who couldn't afford or be burdened with expense or large machinery, it gave them this ability to record themselves. So I'm seeing people say, not at Central Branch, but maybe in other collections, in Brandon's collection. And Anna is saying we have several in oral histories. So yes, that is definitely what I have found. So also if you're trying to, you know, have local organizations like community archives and things like that, use your memory lab. I bet they'll be happy to bring some. Brandon says, sadly, we don't have any audio in our collection, but hey, you know, there's still time. So, you know, you can see that, hopefully you can see on this tape that I have up here, that the maximum number of minutes that this tape can hold is 60. That's what that 60 is there for. And you'll find tapes with lots of other numbers on them. So like maybe 90, and it's, you know, it's 30. So for this one, it'd be 30 minutes on one side and 30 minutes on the other. So total is 60. But you don't know how much is actually recorded on there until you play it, right? Because you can't hold it up and be like, I see this much is recorded. So it's a good idea to keep this in mind for how long users should plan their appointments, if, you know, and maybe for them to manage their expectations about how how much they can digitize in their appointments if you decide to make them 3-hour slots like ours are. That would realistically, a 3-hour appointment with our audio deck at our memory lab, you'd really only get 2 tapes done because there's so much work you need to do prepping and exporting, and then putting it back onto your drive that you bring, entering it metadata, because obviously everyone's going to do that. So you're really only going to be able to do 2 60-minute tapes, and that's something that you want to let people know, that even though there might be only 5 minutes recorded onto this, they should plan that they'll have to at least sit there, that they might have to sit there for 60 minutes in order, because everything happens in real time with audiovisual materials. You have to sit there. There's no jumping the gun. You have to sit there while it plays and the computer records what it's playing. So let's see. The notches on top of the cassette shell indicate the type of tape. So you can kind of see that here too. It says CRM2, so it's chromium 2. But there are these little notches, little holes, on the top of your cassette. And if you have one, take a look at some point, and we'll take a look and go over this when we're in person. So type 1 cassettes have only write protect notches. Type 2 have an additional pair, so that means that they only have one little notch or hole. And then type 2 have an additional pair next to this write protection one. And then type 4, which is also can be called metal, and of course they skip type 3. There's no type 3, so don't worry about type 3. They just went straight to 4. Those have a third set. So if you see 3 little notches, it's type 4, not to confuse you. So that's near the middle, and that third is in the middle. So it's sort of like at the end of the cassette, in the middle, at the end of the cassette, on the top. And what does these mean? It doesn't really matter. But basically the deck, it does matter, but it allows the deck, when you put it in there, the deck automatically sees those notches and then is able to select the proper bias and equalization to play the tape back in the way that it's supposed to. So basically type 4 was fancier, supposedly. And so you want to be able to have a deck that can play all 3 types. That's really important, because you are going to get decks that people are going to donate to you that isn't able to play maybe type 1, maybe it's only type 2. But so like that $500 one that I mentioned can play all 3. So so that's something to really, so these are the 3, things that I focus on telling you guys that will help you in evaluating your deck, in evaluating people's tapes, and that you can teach your public about looking at that tape length, and that way they can gauge how much they can get done in their appointments. And then the fact that it started in 1964, it's one of the longest living audio formats, analog audio formats, I think, and the most popular. So you're gonna see it. You'll definitely have people coming around. And I'm seeing Amy King says, my museum has cassettes in our collection, which is awesome. And Brandon made sure to put yes, that's right. Someday, Brandon, gonna get some compact cassettes in there. Oh, I can't use the arrow. Okay, so remember, perhaps at our last webinar, I put up this Digitization Fundamentals bullet point list, because we all love bullet points, don't we? So these are the fundamentals that I came up with for digitization. And we went through the specifics for scanning. And we're gonna do that now for audio. And as you'll notice, this is all the same as what we went through with the scanning. So now we're just gonna go into the nitty gritty for audio, and then we're gonna do the same thing for video. Okay, so obviously the first thing that we start off with is our analog to digital signal conversion, right? And we talked about the, sorry about that. We talked about the basic idea of analog to digital signal conversion, and how for everything, and how the goal of that is to get an accurate representation of the original, as accurate as possible. They are two different types of signals, so it's not going to ever be exactly perfect, but there are ways that you can get as close as possible. And that means that the closer you get to an accurate representation of the original, the more resources you need to get that out, that representation out, and then also the more resources you will need to take care of that large digital file that you've now created. So the things that will get you to your analog digital signal conversion and that you have to think about in getting that accurate representation is your playback deck for audio. Very, very important part. You cannot get anything off of an audio tape or a magnetic tape without a playback deck, without a working playback deck. So also you have to think of and evaluate the physical condition of the tape itself, because there are degradation aspects and characteristics that will degrade your analog to digital signal conversion, and then also will just further damage the tape. You also need to think about your cables and connections. So how you are taking the signal out from the playback deck, and how you're transferring that into every other peripheral piece of equipment that the signal runs through. Cables are very, very important, because every time you connect an analog signal to another piece of equipment or an adapter, you can lose a strength of your signal. So you want to make sure you have the highest quality cables and connections, and as few of them as possible. And we will go more into that, and you guys will get to see in person during boot camp all the different types of cables, and I will really hit you over the head with that. And then along those lines, it's the quality of your analog to digital converter. Not just, is it a high quality company that makes it, that's well trusted within the preservation community, the AV preservation community, also like broadcast audio professionals. What do they think about this company? What do they think about this particular AD converter? Has it been around a while? Have people tested it? Who else is using it? Those are things that I'm always thinking about for us, especially because it's very hard to find an analog to digital converter that's not thousands of dollars for video specifically. But you also need an AD converter for your audio. And those ones that are thousands of dollars compared to the ones that aren't, that are a few hundred maybe, what's different is not just that it's made with less high quality parts, but then also there are less options for high quality cable connections. So you have those lower quality connections for the signal to flow through. So that means that you don't get as much of the original signal in, and you can't capture as much of the original signal. And so when you're working in a audiovisual preservation unit, and you're trying to build a best practices, digitization lab for AV, you need to have an analog to digital converter that will have the utmost, highest quality, least interference AD converter inputs and outputs. And we will be able to see during boot camp options of what those look like. We're going to be going to the Smithsonian's National Museum of African American History and into their media conservation department, and they have an amazing setup, so you'll be able to see how best practices works there and what it looks like, and you can compare it to what we're doing. So we try and have a balance, once again, of we can't afford to do those best practices, and the public is not going to need all those bells and whistles, and they'll be way too overwhelmed by all of them. But it's very important for you guys to see the difference and to know the difference. So once again, you've seen this diagram before, but basically, a digital signal is more of these, ones and zeros, and is so more binary and less of this fluid analog signal. So basically the more, you know, time, basically we want to get that blue line, sorry for anyone that's colorblind, we want to get the blue square looking line as close to that green fluid analog line as possible. And that is our goal for A to D signal conversion with audio. The major way when we're talking about physical condition that magnetic tape degrades is water molecules from the atmosphere get stuck into the tape's binder and the magnetic particles themselves. So the binder is the thing that keeps the magnetic particles and the lubricants and everything together on the one side of the tape onto the plastic base, right? But so water comes in from the air and it basically takes that and changes the molecular structure of the binder, and the magnetic particles start getting, everything starts getting sticky on that side, and they can flake off and stick to all of the different moving parts that the tape needs to touch. Sorry, we have these motion detected lights, so I have no control over that. So basically, you can see here, I have never seen audio sticky shed syndrome like that, and that is the name for the what happens when the water binds and creates the stickiness is called sticky shed syndrome. People also call it binder hydrolysis. So if you hear any of those, that's, most people call it sticky shed. I've never seen anything that bad where that's like literally magnetic particles flaking off the tape. But typically the image on the right, I have found where you play the tape, you hear some squealing and you kind of see you see that the tape or the playback deck is working harder than normally to play that tape. Normally if I see that and I hear that little squeal, I'll stop and I won't. But then another key tip that you have sticky shed syndrome, because there's no way of knowing until you start playing it, is that you have you play the tape on and then you go to clean the heads and the moving parts that the tape touches, and you have a bunch of magnetic particles on your little Q-tip that was not, shouldn't happen after playing for a few seconds. That's not dirt, that's magnetic particles. So we definitely, anytime that you suspect a sticky shed syndrome tape is happening, then you need to stop playing them as soon as possible because they can damage your playback decks, and it's damaging the tape as well. So good storage, and that means cool and low relative humidity. That is what helps prevent this, but not completely. It really can depend on what company manufactured the tape and when they did it. So what they put into their special sauce. There's certain Ampex, AMPEX tapes that people know, like, it's just like, oh, that's gonna have sticky shed. It just is, because that's whatever they put into their special sauce, Ampex, for that specific brand, it just, for some reason, really likes to hang out with water in the air and stick onto your playback decks. Luckily, you won't see that too much with VHS. There is an Ampex tape, I need to get the number, I have it written down, so I'll share that with you guys, and that is very typically a VHS that will show sticky shed. And I have an example that actually, I came across it last year, and I digitized a little bit of it, and then you start seeing what happens when you start going into sticky shed with VHS. So I'll share with you guys so that you guys can keep an eye out for that specific VHS. But otherwise, it's really not something that we, that we come across with the memory. I honestly, when I first came on with the MemLab network and looking at DCPL's MemLab, I was like, wow, I am surprised that you don't find that that's not like a problem. But VHS is a very resilient format. And same with compact cassette, audio compact cassette. You can get that, you can get Sticky Shed with that, and you need to keep an ear out for it. But it's basically, and you'll be able to hear it from the deck, like, so you need to train whoever is overseeing the memory lab if they hear the squealing, and also, you know, tell your patrons as well, like, you need to stop, you're damaging your tape. So anyway, that's a really important aspect that I don't actually think you will run into too much, so don't worry too much about it, but just, you know, it is something you need to know. A good way to get a transfer of, or to digitize a tape that's suffering from Sticky Shed, there is an option, is to bake the moisture out of the tape. So send this to a vendor, please don't do this in-house. Basically, you need a good quality, like scientific grade oven, and you have to take the tape out of certain enclosures, and then it's baked for like 48 hours at a certain temperature, and then it's digitized after that. And eventually it will, the Sticky Shed will come back. So it's not like it's gone forever, it's just gone long enough in order to get the signal off of it and at least create a digital copy of it. So a lot of, there was some debate initially about like, oh, well, it's could be harming the tape more, so can we ethically do that? But since we're trying to get the content off of, and the only way to really preserve anything on magnetic tape is to get it off of the magnetic carrier. That's how horrible magnetic tape is in the long term, that it was worth the risk and the damage that baking a tape would eventually put onto the tape itself. And then obviously, as I said, good storage does help, although not completely. The best way to store audio, just for your, you know, if you can very easily tell this to your patrons, or implement this, is vertically. You want to store audio vertically like a book, like we have here, ideally in this polypropylene case. And polypropylene is an inert plastic that doesn't have anything within it that will further degrade, like acids or water or things like that. That will further degrade the items that it's being stored in. So remember how we talked about our file formats, and then our codecs as well. And for audio in particular, our preservation master for best practices is a lossless compression. Thank you, brain. And that is broadcast wave file. And people also call that BWF for short. And that is your format or container, as people call it. And then your codec is linear pulse code modulation, but you don't really need to know that necessarily. But once again, I'm just kind of putting that out there. And then a very good typical access, you know, streaming format is a lossy compression. And I didn't type MP3 twice. It's actually the file format is MP3, and then the codec is also called MP3. So that is just something I want to put out there, because you'll get that question a lot. What is, like, what's the Library of Congress doing? You know, and you can say broadcast wave file, and LPCM. So also Brendan says that he found this in this new collection today. Cool. I'll have to check that out. So I also have a cassette player at my house, Amy, and because all my friends have all their music on cassettes now. So also I'm a big nerd. The other part of best practices, that when people ask you, what does Library of Congress do for their audio? This is the next part that you'll tell them about, and this is what I'm clumping under that bullet point of resolution. Digitized audio is a series of snapshots, as much as audio can be a snapshot. So the digitized audio is the series that we hear as continuous sound. How often these snapshots are taken this is referred to the sample rate. And the more snapshots taken, the more detail the sound has. So, right, so this is the more snapshots taken, the less that those edges are so harsh, and this just means it looks more like that continuous analog waveform. So the sample rate defines the frequency response. Okay, this is getting way too technical, but the frequency response as it divides up the horizontal axis of the sine wave. So that's this. So how many times is it sampled over time, basically? The minimum sampling rate that you would want for anything would be 48 kilohertz, and that's how you measure your sampling rate, okay, is in kilohertz. I'm sure I knew why at some point, but so when you're saying best practices, right, you say broadcast wave file, your preservation master, broadcast wave file, you don't have to say the LPCM, most people don't even get that far, and then 96 kilohertz for your sampling rate, and then still within this bucket of resolution, you also say 24 bits. So 96 kilohertz, 24 bits, broadcast wave file. That's what you would say as your preservation master file. Bit depth, so here we're talking about bit depth within this 24 bits resolution. Bit depth defines the dynamic range of the sound as it describes the amplitude, the vertical axis of the waveform at each sample point, okay? So how many times you sample each sine wave. It's very similar to your sampling rate. Both of the resolution aspects, this slide and the previous one, so this one and this one, resolution aspects. These are the best practices, as I mentioned, for high quality resolution. The more you crank these up, the higher the resolution and the higher the size, or the higher the file size, the audio file size. So 96 kilohertz, 24 bits is pretty large of a file for audio. What you're gonna get typically on your compact disc is 44.1 kilohertz and 16 bits, if I remember. I'm pretty sure I committed that to memory. So that's just sort of an idea of, CD is kind of like minimum of what, for digital audio, what our ears are happy with. So basically, hopefully you guys can see how having, you have your original waveform up at the top, and the more bits that you have within your bit depth, the more depth that you have of your bits, then the more that it looks like the original waveform, and the more that the closer that you are representing the original signal. So the next part under resolution, this sort of fits into resolution. It's more about having a quality signal. And this is, once again, best practices. You would, clean your decks, your playback decks heads regularly, your capstan guides as well, which are the things that move the tape through. And you would do that regularly. I'm going to teach you guys how to clean your audio decks, how to clean your VHS decks. You're going to have to do that. It's very, very, very important. But other things that I'm not going to teach you how to do that would happen in a preservation lab is demagnetizing anything that is metal within the audio deck after you clean them. So you can do this they do have these demagnetizing cassette decks out there. So you could potentially do that, and you just basically just kind of play it for a little bit and it'll demagnetize your tapes. And you do this because tape heads and guides tend to pick up, especially the metal parts, pick up magnetism from the tapes because magnetic particles, have magnetism from the tapes you're playing and rewinding over time. So the magnetism can slowly erase the high frequencies on your tapes, as well as creating like additional noise when you play it back. So it can also make it hard to calibrate your deck. And so these are just things that, you know, that labs do every now and again, pretty regularly, in order to make sure that they're just getting the absolute highest quality playback and representation of the original as possible. This isn't something that we're pushing for you guys, although deck maintenance at a vendor is something that you'll have to think about, because yes, eventually your decks will stop working properly. Okay, so as I had just mentioned the word calibration, and calibration is the process, and we did talk about calibration a bit before, but it's the process of matching characteristics or behavior of a device to, or a piece of equipment, to a set standard, okay? And then I'm putting calibration under QA or quality assurance because it will make sure that there will be less errors and it'll be more high quality. You are more assured of your quality. So speed is very important for calibration. You need to make sure that your playback deck is going at the right speeds. Azimuth is the angle at which the tape is hitting the head. You don't want your levels to be too high, or so moving on to levels, you don't want your levels, your sound levels, to be too high, or you'll lose sound information if it peaks. EQ stands for equalization, and this strengthens or weakens the energy of specific frequency ranges. So you can use an EQ filter, for example, probably in some like audio software, to cut out like higher frequencies. Bias then is a signal that is used to excite the tape's magnetic particles to basically allow a higher quality recording. That's all you really need to know about bias. And EQ and all these things is just basically, you know, all of these things are going to contribute to what your tape is going to, your digitized audio file is going to sound like. And there are ways that you can calibrate these in a preservation lab environment. Signal tests and targets are another aspect of quality assurance, or QA. And so here you can have tapes, a test tape that has reference tones on it. And you know, you use machinery also, like this example here is an oscilloscope. So you can use that to calibrate your deck with the tape. So you basically, within a preservation environment, you look at all of these various pieces of equipment and you play the tape back on the deck and you evaluate, you say, this is what it's supposed to look like. Why doesn't it look like that? And then you can fix things accordingly in order to make sure that everything's calibrated. And that way you'll get the best possible digitized audio file. What exactly is in that file container format or container? There is an audio stream, of course, and then we also have an ancillary stream of information, and that includes metadata, timecode, and captions potentially. So there's two parts that go within an digital audio file. And as far as embedding metadata goes, I always put up this basic guidelines for minimal descriptive embedded metadata. And I mean, I just ignore that end part where it says in digital images, because I mean, I think it's just a good thing to read and to think about for any kind of basic minimal descriptive embedded metadata. So I recommend you read that while it's focusing on digital images. I think it's just a good guide in general for thinking about your basic embedding of metadata and why you want to do that. So there is a tool called BWF Meta Edit where you can store this metadata information into your file. So it does actually go in that ancillary stream of the file. And so that way, that information, even if it gets separated from your database or your other, if it's a personal digital collection, gets separated from a hard drive where there's an Excel sheet that says what it is, then, or maybe it gets accidentally renamed, and you have a lot of descriptive information in the file name that gets lost, then at least this is the stuff that's embedded, and you can know what you have. The last part of audio digitization, and pretty much any, is quality control, or QC. And you're going to spot check. You can't listen to the whole thing again, right? That's way too much time. So you spot check the beginning, middle, and the end, just to get an idea of how everything sounds. Is the speed right? Are there tons of errors going on? And the AV Artifact Atlas, which you can click out here to, which I really recommend that you do check out, that will help you in determining something, an error, whether it's something that's inherent in the audio signal or not. That takes a bit of practice, but honestly, what you're really looking for with the Memory Lab is just like, is there audio? Can I hear it? Does it sound, you know, is there something wrong with the sound? And usually things will go wrong in the beginning or the end typically, and then you just kind of check them out. Once again, you can also use a reader to check your embedded metadata. Another aspect would be a Fixity check, which is running a checksum to make sure that no bits have flipped in the making of this digital file or while embedding the metadata. So that, or after embedding the metadata. So that's something that we could talk more about, but once again, that's more of a professional, you know, audio preservation, digital preservation setup. So that is that. And then I wanted to point out the space within our Memory Lab where we have our audio cassette deck down there at the bottom. And then, you know, I'm going to share these slides again with you guys, and you guys can click out to see our workflow and the equipment that is specifically in our Memory Lab. But you can't buy this deck anymore, unfortunately, but there is an equivalent that I have researched. That's the $500 one. So I can always, and that's also on our LibGuide. So it's just, I know that the LibGuide can get really, you know, overwhelming. So if you ever just want me to be like, can you just send me that, a link to that audio deck, just ask me that in the audio channel of Slack, and that way everyone can see it. So once again, I know I'm going to try and kind of scooch through this, but just to make sure that we have time for questions. But next up is video digitization, and you know, we're going to move along and talk about the specifics of video. Once again, IC is video means in Latin. And this diagram is an NTSC, I totally forget what that stands for, NTSC color video signal. And this is, NTSC is the type of color signal that we use in the United States. So when you're, you know, this is typically your color video signal when you're watching. This is actually what it is, broken down. And you don't need to understand this. I'm showing you this because I showed you the audio, which is much easier to understand and to look at and to think about representing, you know, creating that original sine wave is much easier to think about than like, how do I get all of this? So this is really just to show you how complicated video is, and it just keeps getting complicated, more and more complicated as we go along. So don't worry if you feel a little overwhelmed. And this is just a refresher, and because as I mentioned, just love this awful, awful diagram. So once again, we're working with magnetic tape with video, and it's the same concept as your audio magnetic tape. There are just as many formats. There are more, actually. Sorry, there are more formats. So I have here at the top just like a listing of some of the more popular ones at the top. So there's 1-inch reel-to-reel type C. So there's also like different types of 1-inch reel-to-reel. There's pneumatic low band, pneumatic high band, pneumatic SP. We've got VHS, SVHS. There's also VHS-C, which you will see a lot of. There's Betamax. there's beta cam, there's high 8, there's digital 8, there's regular 8. Like, you get it all with video. So many formats. Almost all video formats that you will come across are helical scan, is what they call it. And that's how they figured out how to fit everything onto video. All of this information that you saw in that first, they're like, that's a lot, especially with color video in particular. You know, with audio, it's audio, an audio stream, right? You're just trying to represent, sure, there might be 2 channels and maybe multiple tracks that you're trying to fit on there, but you're not trying to fit an actual visual component as well as audio. And then once you add color into it, it's like, it just requires so much more space and information. So they figured out that they could store it onto magnetic tape, store the signal in this like helical scan, which is basically like this diagonal. They can store more when they do it diagonally. So that is basically that. I have a little, you can click out here to a really fun video of Julia Child in the 60s splicing videotape with her like butcher knife. And that was actually the first videotape, which was 2-inch quad. It was a huge, so it was 2 inches wide, right? And just a huge format. And that was before they figured out the helical scan you are able to shrink the tape then, because you can fit more information on it. And then that's when they start making the cameras smaller and the playback decks smaller. So it started out with 2-inch video in the 1950s. That was, the playback decks were bigger than a refrigerator. So, and like a tape was like 30 pounds, maybe more. I have no concept of what things weigh. So we're going to be focusing on VHS and VHS-C because that is what you guys are going to see just so much of. That is our most popular format by far, far and away. So I do have my VHS-C here, and it's this little thing. And that came around in 1982, but then I did have my VHS here as well. And VHS itself came around in 1976, right? And I think everyone's pretty familiar with that format. So this is just a basic what your VHS, the tape gets pulled out, and then what it looks like inside of the deck. So it's going to be something you guys will see in person because we will be opening up decks, like I mentioned. And you'll get to see this, and you'll get to clean video heads by hand and really get an idea of like what's happening inside and why you need a high quality deck, and make sure your tape is in good condition. So I also have here with me this adapter, basically to take your VHS-C tape. You'll need one of these, and we'll be buying you guys them. And you put it into this adapter and close it up, and yep. So it pulls the tape, the adapter pulls the tape out of the little cassette shell and makes it look like, basically, it makes it look like a regular VHS that you have. So now you can just pop this in and play it in a deck. So next, as I mentioned in all the other digitization webinars that we've been talking about, is these digitization fundamentals. So same as all the other ones, but the devil is in the details. And that's what we're going to get into right now. This is exactly the same. This is exactly the same slide, and I did that on purpose, as your audio AD, analog to digital signal conversion slide, because the goals are all the same. The issues are all exactly the same. So I'm not gonna, go over this again necessarily, but all of these things are so important. They're different. There's different aspects of your playback deck, and not necessarily physical condition, as you'll see. The same things go wrong because it's still magnetic tape, right? But the cables and connections will be a little bit different, and then your AD converter will be different as well. because of those connections. So, but the idea is you want the highest quality cables, highest quality AD converter, and we are going to be falling somewhere in between those. I've already explained what sticky shed syndrome is, and that is exactly what happens. That's the typical thing that happens with VHS tapes and with magnetic video tape. So, and this is something that you can see within this image. Basically, you will hear the squealing as well, because basically your playback deck is having a hard time working properly because things are sticking to it. But then also, since you have this oral representation, you can see that a lot of those particles are sticking into the video heads. So you're getting that like snowy image, but it's not the typical snowy image. It's could be complete loss of visual information, and or it could be a little bit different. And as I said, I have a actually, before I upload the slides, I'll probably upload that video to OSF and put a link in this top under physical conditions, so you can see that example of a sticky shed video that I recorded. And then once again, baking and storage is still something that will help, but really digitization is the way to go for preservation for video, for magnetic video, well, any video. So any analog video or digital video that's stored on magnetic tape, sorry. So also storage, you want to have your videotapes stored vertically, much like audio. The only thing you want to store flat is film, and film starts with an F, so store that flat. Everything else vertical like a book. So now we have our, if people are asking, what's the best preservation? You know, what are the preservation, you know, what's the Library of Congress doing? It's less clear with video. When I first started in this profession, it was a little bit more all over the place than it is now. There were kind of like 3 options floating around, 3 to 4 options floating around for what your preservation master could be. There was not a standardized format and specifications like with audio. But right now, I feel like I can very safely say that the safest bet that most places go with is, but I'm pretty sure it's not actually what the Library of Congress is doing. They might still be doing JPEG 2000. Don't do JPEG 2000. The Library of Congress might be able to pull that off, but no one else will. Uncompressed MOV/QuickTime, if someone says MOV or QuickTime, they're interchangeable for your file format container. And then V210 is the codec. And then that is in uncompressed format, okay? And then there's also, this is where I'm moving, just if you guys want to know, if you guys care. I'm moving away from uncompressed MOV V210 for my preservation masters, because they're 100 gigabytes per hour. And I have worked in places and do volunteer with places where we have thousands of hours of video, and that's just not gonna cut it for digital storage. 100 gigabytes per hour, no. We've moved at the Mid-Atlantic Regional Moving Image Archive, Marmia, where I volunteer. We have moved to Matroska as the file format, and then the codec is FFV1. And this is much smaller. I think it's like 2/3 smaller file size. Like if it's 100 gigabytes per hour, maybe it's like 35 gigabytes per hour. So it's compressed, but it's lossless compression. And then for a, and this is like a newer thing, but it's really starting to be used by more and more organizations and being supported way more in the open source community. So I'm feeling very positive about it. And then it also gets playback in VLC player, FYI. And then we have your streaming quality file would be a lossy file format compression, and that would be an MP4 with H.264 codec. So when we're thinking about the resolution bucket for video, there are a few aspects to think about. Traditional TV systems like that, what I mentioned, NTSC, that was the analog TV system within the US. This used what was called interlaced scanning, okay? And this is where half the picture appears on the screen at one time, and then the other half appears at the next time. And this is how it tricks your eyes. Basically, it's one half is shown, and then 1/60th of a second later, the other half of the image is shown. And your brain doesn't notice these separate images being shown to you, and they just mush them into one because they're so closely set next to each other, and you can't detect that they're two separate pictures. They look like one picture. So that's how they were able to store this information all that information into the video as well. And that's how analog video was traditionally shown and stored. But now we use progressive scanning, and this is what will be happening on your computer and on your flat screen. This is where the entire picture is shown, is painted basically at once, and because there's no need for tricking us because we're not worried about that physical storage of the signal onto a tape. So here we get to Gilbert. Gilbert is demonstrating for us nicely the difference between interlaced and progressive, at least on a digital, in a digital world. You get this artifacting, this like interlacing artifacting that you can see, especially when it comes to movement. A lot of times you see this, the horizontal lines, right? Sort of like these shades back here. And that is, especially when you take an interlaced video and then show it on a progressive monitor, okay? Or typically, because you wouldn't necessarily see this if it was on you wouldn't see this, this kind of or artifacting, excuse me, if it was shown on a classic analog CRT monitor, which we will provide you guys with a CRT monitor, which actually I recommend that you only use when you need to. So don't keep it on and leave it on for patrons, because they'll actually look at that. And I've had this happen multiple times. And some memory labs that I visited, not part of the network necessarily, but they don't have one of these. And their users are so happy. They think that the image that they're getting, that they're digitizing, is so good. They're like, I'm so amazed at what quality I was able to get off of this old analog piece of format. But when you have that professional CRT monitor that we're going to give you next to your progressive monitor, they compare them and they're like, why doesn't my computer look like that? And they get upset. So I really recommend that you'll have it there, and it is really important to have the CRT monitor for troubleshooting. And maybe if you like have a donor coming over or something like that, and you want to kind of have this like fancy looking thing going on where you can see the image there and then see it in the computer. But I would say turn it off otherwise, because people are going to wish that they had this. But if you do keep it on and people ask, then you need to explain to them that this is a a professional monitor that was built specifically for viewing analog signals, and that gets lost in the translation when you digitize it. It's just how it is. Sorry. So we also talk about resolution with video. There's so many levels of resolution for video. And this, I think everyone will probably be slightly familiar with. HD, right? Anyone? heard of HD, so that stands for high definition. But what you're going to be really working with is SD, which stands for standard definition video. And this is just when you think about when people say, you know, 12 or really like 1080 by 720 sort of things, like this is what, or 1080 by 1920, this is what they're talking about. It's just the higher the numbers. So it talks about the aspect ratio, and you can see that 640 by 480 standard definition is that 4:3, like what you're used to, old school video, right? But then once you start getting into high definition, it's more of a widescreen format. So it's talking about that, it includes that aspect ratio, but then it's also about the size of the resolution. And then that little I at the end, when they talk about this resolution, that stands for interlaced. So if there was a P, that would stand for progressive. So with your VHS, you are going to be going for your first standard definition, SD. Another part of resolution with video is color space, and so here you're gonna hear similar things of bits, measuring things by bits, and sampling rates. So chroma subsampling is the practice of encoding images, video images, by implementing less resolution for the chroma or color. Chroma is interchangeable for the word color. Information. So you use less information, or less resolution, excuse me, for your color information than for your luma, which stands for your whites, your darks and your light. So it's like sort of a grayscale, but it also includes white and black. So luma is what that means. Okay, so taking advantage, once again, of how our eyes, human, like our visual system is built, and how we notice differences in luminance, luma, in those changes of whites or lights and dark. We notice those way more than changes in, sorry, someone just brought their baby into work. I'm so excited. Oh no, I need to be quiet. Okay, sorry. Babies. Okay, so chroma subsampling. We are way more sensitive to the lights and the darks. And so if we want to save some space in a digital file, we're going to take away color information. So that is basically what this is doing when you talk about color space. You could have a digital file that is a 4:4, has a 4:4:4 color space, and the first 4 stands for your luma, your luminance information, and then the next 2 stand for your color information. So if you had 4:4:4, that would be a super high resolution and have all of the chroma, so color information, and all of the luminance information and lights and darks. But what most people do to save some space is they have 4:2:2. So they half the color information, but they keep the luminance. So that's what that means if you ever see that. And if a vendor talks to you and asks you, what do you want? Do you want 4:4:4? Do you want 4:2:2? Go for the 4:2:2. That's really is the standard. So you could also 2:2:2 if you really want to. And then basically it will reduce your bandwidth of your video signal with no visual difference, okay? YUV is another thing I want to mention that you'll see and potentially hear. It's a color encoding system, so it has to do with the color, the chroma, and it's typically used as part of like a color image pipeline where it encodes a color image, taking video perception into account, and it just basically works better with interlaced. So since you're going to be capturing with any analog video information, people go with YUV as opposed to RGB is the other option for your color encoding system. Go with YUV because it just works. It plays better with your analog interlaced video signal. And then of course you have your bits that, once again, it's the same idea with bit depth of if it's 8-bit, then you have, it's a smaller file, less resolution. I would say 8-bit is fine, and it does have to deal with the color, excuse me, it has to do with the color. And 10-bit is higher. 10-bit is the preservation master standard. So this 422 color space with a 10-bit YUV color encoding scheme is what you are going to say to a vendor. Although if you bring it down to 8-bit, I don't think many AV archivists would fault you for that. Some might, probably would, definitely would, but not this one right here. So another aspect of resolution with analog signals is how, this is where we're talking about our cabling and our inputs and our outputs. So don't know if we have any Dune fans here, but the signal must flow, right? It's all about getting that video signal to be as close to the original as possible, and being able to have a playback deck that has the highest level outputs, and then using the highest level cabling from those outputs into all your other peripherals, like your analog to digital converted. Thank you, underrated David Lynch movie. I know it. I don't like many David Lynch movies, but I love that one. So anyway, basically there are 3 types of ways that you can pull out your video signal from your playback deck. Ideally, and not all, so basically the first type that they had when they were developing video was just the standard composite video signal, okay? And this is where everything is all stored on one, or not stored, but sent. So it's this idea of a pipeline, right? The signal must flow. If it's water that is flowing where water is a signal, flowing through the pipeline. It's one shot, it's going through one cable. And I do have one of these. And this is an RCA cable, which I think everyone will be very familiar with. And then you can see here at the bottom of the image that I have there is the input of where, or output of where I would plug this in. So this is the cable where you have your analog video signal all traveling together, jumbled together in this little cheapo cable. And not only is, so basically what the Y is standing for here is that luminance, okay? So there's like, that's why it's gray, the grayscale, right? The lights and the darks. And they are traveling alongside the U, which stands for, which is really the blue, but it's blue minus Y, which is, it's a subtractive type of color system that will also help you get your greens, but you don't necessarily need to know that. And then the V stands for your reds, which also, it's actually red minus Y, which helps with the blue, helps you eventually get your greens as well. So, and all the colors that you need to represent your analog video signal. But all of them are being just mushed together and sent into here. So you lose a lot of that through this cable. Not just that it's cheap, but also just the fact that you can only fit so much on this little guy. So then they came up with, so for example, if you get a U-matic deck, you're not going, the only option that you have is composite video out for that one, because it was in the first, cassette video format, and it's just not possible. They didn't make decks that had anything more than that. But they figured out that, hey, we really need to figure out a way to make the video signal higher quality, because people really need this and people want it. And that's just constantly what we're always trying to do, right, with our phones and technology, is level up to the next thing so that people will buy it and have a little bit more resolution. And so they come up with S-video. I do have an S-video as well. And S-video, again, you will know the difference eventually. I wonder if I can make the zoom. You can see the 4 little metal prongs in there, and they have separate little wires where the Y, or the luminance information, is traveling. While it's one wire here, it's a little bit thicker than that. This is a little bit more well made. And so you have they're able to fit more information, so more resolution, whatever. And the Y, the luminance, is traveling separately, all by itself. And then the color, the chroma information, so your reds and your blues there, are traveling separately, well, together, but separately from your Y, from your luminance. So you just get a higher quality resolution that way, and it's all what's happening inside of those pins, so all happening inside of here. It's almost like pipes within one pipe that the signal flows. So that is ideal. You really want an S-video output, and we are going to be getting you a deck. So S-video came around with SVHS video, and that was in order to squeeze a little bit more resolution out of VHS, and that's what we're going to be getting you guys, is an S-video deck with those outs. And so that way you can get a little bit higher resolution, and that way, in case people bring in S-video tapes as well, S-video decks will play S-video tapes and regular SVHS or VHS tapes. So also, lastly, I want to talk about component video, which you guys won't be using, but that came around with Beta Cam, or is it Betacam? Yes, with Betacam, which is, oh wait, is this Betamax? Yeah. Anyway, with Betacam. So Betacam was a more professional video format, still analog, but they were able to figure out that, and I don't have these cables with me, so sorry, I can't show them to you, but you will see them, a certain type of, and they're showing on this diagram here that they look like RCA cables. And you can get some that are like that, but the ones we're gonna be working with are not like that, okay? They're much higher quality than that RCA. They have like a locking mechanism, they're called BNC. And so you will get to know them and see plenty of them when you're here. But basically what happens is, it's even better because you have 3 cables, okay? 3 separate cables like this, and 3 separate outputs from your deck and inputs within all of your peripherals, if it's your analog to digital converter or your time-based corrector. It all has these 3 inputs for the luminance and your 2 channels of color. So anyway, that's higher resolution and for your video signals. Another thing to think about, especially with VHS, is your speed, because there are different modes and different speeds. So for example, for this tape, you can get up, if you use it and record it, let's say, you know, you're like, I want to record all of the Golden Globes. Don't know why anyone would want to do that. But if you wanted to, and it was very long, which usually they are, then you could like turn it on, or the Olympics, maybe that's a better example, where someone wants to turn this on all day and then come home at night and be able to watch it. This would be able to record 8 hours of much lower quality video signal. That's how they're able to squeeze that 8 hours onto what's normally not 8 hours, but more like a 2-hour tape. This was more of a consumer. This was absolutely a consumer thing to do, and for consumer decks only. So the deck that we're going to be buying you, they're like magical unicorn decks, where not only do they have S-video out, which is more of a professional thing and can play SVHS tapes, but then they also can play multiple speeds, which is great. But that's also why we recommend that you do take the consumer format, or the consumer decks that people are going to just shove at your door. We really recommend that you take those, because those are really helpful if you have a really fancy professional deck, SVHS deck, which we have one in our, if you want to take a look at the SVHS deck that we have in our memory lab, it's a high quality professional deck. but it won't play these slower speed tapes. It won't play them properly at all. So we have actually a consumer grade deck that someone donated that we just plug into all the peripherals if someone brings in a tape and we're like, oh, that's an EP tape. So that's a very important thing that you guys will run into. Oh, dear. And EP stands for extended play, sorry. Another part is your quality of signal again with resolution. And this is all the same as video, like your deck maintenance at a vendor. You want to do your own deck cleaning in-house. And then the other thing, which I already mentioned, and so sorry about that, I should have waited, is a TBC, which stands for time-based corrector. And your time-based corrector, basically, this is a really important part of the memory lab that when I first joined the memory lab network, I was like, why do they have a TBC? Maybe I'll get rid of that. And I really have found that that's an important part that makes the memory lab more than a typical like at-home video digitization setup. So while it's now the kind of TBC that we need, I mean, you could spend it, basically we found one now that costs about $800. And then from there it goes up to like 3,000. And when we first started this, there was one out there for like $200 that worked great. But it's less and less places are manufacturing them. So at that level, which is, you know, has that S video, but doesn't have all the other, doesn't have the component, which it has those, which is the more professional grade. So we just wanted that sweet spot of the in between S video, and that's getting harder and harder to find. So we'll talk more about time-based correctors. I had it on my to-do list to write like a blog post on time-based correctors, but it's one of those things, it's like the difference between a file format and a file codec. It's like, it's one of those things that is important, but like, just know that we're gonna have a TBC. You're gonna need to flow the signal through that to really stabilize that image. I found that the AD converters that we're working with really prefer to have a TBC, to have this video signal run through and be stabilized through a TBC before it's run into the analog to digital converter. It just makes it happier. So we're gonna have this, you are gonna have this, and I want to be able to dive more deeply into the technology of it and exactly what it does, but in a non-technical way. But that takes a lot of time because mostly what's out there is like for video engineers. So TBD for the TBC blog post. Then we have our calibration once again, part of quality assurance. And with video, as I mentioned, you have your CRT, which stands for cathode ray tube. You have your CRT monitor that you'll be getting. You also have a computer that you can look at color bars through. And the color bars, you can visually see them on a CRT, but then you can also look at them through these scopes down here. There's also this other aspect of sync. So making sure that there are these synchronizing pulses that are actually stored. Remember the first slide I showed you for video that was just meant to overwhelm you? There are sync pulses within the video signal in order to keep it everything synced, basically. So make sure nothing gets out of alignment. You don't have audio that's 1 second later than your moving mouth. So those are other aspects that you can calibrate and look at through your scopes and through external devices that you can send out a synchronizing pulse to sync everything within your video rack, where you're not going to have one of those. And you're not going to have these scopes that you see at the bottom there. There's a waveform monitor and a vector scope. And this basically, your chroma levels and your luminance, it's just, you basically look at your color bars and you can use a TBC or processing amplifier part of the TBC to just tweak those and be like, oh, I have color bars. I'm going to make sure that my whites are exactly what they should be. on the levels, and I'm going to make sure my blacks are what they should be, and make sure my yellows are perfect and fitting perfectly in their little target areas. So once again, this is more of a preservation digitization lab setup. And here's what the color bars, and then a lot of times there's an audio signal tone that gets sent in order to calibrate video and the audio accompanying. Within a digital video file, it looks very similar to a digital audio file, but you just have more because video is more. It's extra. It has your video stream, and then your separate audio stream, and then you have your ancillary stream of metadata, time code, captions, etc. Once again, this is basically the same slide, talking about embedded metadata. It's the same reading that actually applies to digital images, but just is talking about, to me, it's just this overall idea of minimal descriptive embedded metadata within your files. So we have part of the workflow for the memory lab is that they take their fancy large files, and they can keep those, sure, as their preservation master files. We don't recommend it because those are huge, but then we have them compress the files into an MP4, and then they can take those MP4s, and by using this free tool called MetaZ, they can embed minimal descriptive embedded metadata within that. And we can play around with that at the bootcamp if we have time, but you can always play around with, like I said, that's free. So for quality control or QC with video, it's the same as audio, where you spot check visually and audibly the beginning, middle, and end of your video file. You want to use a reader and check your embedded metadata, make sure you spelled everything right and that everything's there, and that if you put in a date, maybe it didn't, get saved in a wrong format. And then you would want to do a Fixity check or create a Fixity check, create a MD5 checksum or some sort of MD5 checksum. And then I have at the bottom there's this other option of a frame MD5 checksum for video signals. And I'm sorry if this is overwhelming. I just want to put this out there if you're interested in checksums, where normally an MD5 checksum is for the entire file. You just get one checksum for the file. A frame MD5 checksum actually takes an MD5 checksum and makes one for each video frame, which there's like thousands, right? Within, and then so you get this text document that has a MD5 checksum for every frame of video within your digital video file. Really epic. So that way, if something goes wrong within the file, you can actually track it back to the frame, the video frame. I'm pointing out QC tools as well. This is a free tool out there where you can conduct quality control using it. I recommend looking it up. It's very interesting. Hopefully there'll be more tools like this out there. But it's much more used in a professional preservation lab environment. And then the AV Artifact Atlas will help you go through and look and say, hey, is this artifact something that is naturally inherent in a VHS signal, or is this something that I created myself in my digitization? Or is something going wrong with my deck, sort of thing? Or can I fix it with a new cable? Things like that. And then lastly, we have the real life memory lab here, and I link out to the workflow. You can also link out to the equipment. And here you'll see our CRT monitor at the bottom there, and then the fancy professional SVHS deck, and then at the top is our time-based corrector. So that is IRL memory lab. And then also I wanted to throw out, so there's our equipment link that you guys can follow. I wanted to throw out these wiring diagrams. You guys are going to get into the nitty-gritty of this, but this basically is another view of this. It's like the back end of, so here's the front end. You're like, oh, cool, it's all connected somehow. This is how it's connected. So this is actually a roadmap telling you which cables to use. You can see at the top there, it's S-video, there's an RCA, stereo, composite, Thunderbolt, and things like that. So it actually would tell you if you follow this. I know it seems a little overwhelming, but this can actually is a roadmap showing you exactly how to plug everything in, where to plug it in, and how to get the signal flowing properly from the VCR through the TBC, and then separately sent out of the VCR into the monitor for troubleshooting. And then, so from the TBC, a video signal gets sent to the analog to digital converter, and from the analog to digital converter to the computer. So, wow, okay. So it's a lot, I know. But I would like to take some questions. I know it was sort of crickets last time when we had time for questions with digitization for scanning, and that's fine. I really think that it's a lot to throw at you guys if you have no background, especially if you have no background in audiovisual materials. So, I mean, if there's anything glaring that's out there, I would love to hopefully answer for you guys. Let me just stop sharing my screen. And you guys can unmute yourself, right? I don't have to unmute everyone. Okay, cool. So yeah, any questions about the AV digitization? Ooh, I also see in the chat box that Jonathan says that all of their audio cassettes are being digitized by California Revealed right now, which very exciting. Pamela is one of my favorite people ever. And Jonathan also says, I'm still processing all this information. Me too. It's a lot more technical than, yeah, I know, than my usual method of plug it in and see if it works. But actually it's not. That's exactly what we're doing. Like, it's just, and this is why, so I gave this talk, I gave the audio talk one day and then the video talk the next day. So I'm squishing it in even more this time. And I'm doing that, I thought, via, and please let me know, we'll be sending out evaluations and things, like, please let me know if it doesn't work after boot camp, like, because the idea is, like, there's just some stuff you have to throw at you guys in this PowerPoint lecture-y style that I hope, and I think, I'm pretty positive, will make so much more sense when you're here and I'm throwing these cables at you and you are literally just plugging it in and seeing if it works. And then once you do get it to work, then you'll be like, oh, that slide makes so much more sense now, right? Or that wiring diagram scared me so much before when I saw them projected to me or on a sheet of paper. And then when I started plugging things in, I was like, oh, that makes so much more sense now. So cool. Okay. Cable hookup slide. Woo. Yes. And that documentation should be out there. Just we have so many resources out there. I'm trying to, like I said, put it all into one place on the resources tab of our website, memorylabnetwork.org, but it's not all there yet. So, and we're getting ready for you guys to come, and we're gonna make sure everything like flows smoothly for boot camp. So that'll be all next week, but I did wanna, I'm sort of working through the itinerary right now, just cleaning some things up for boot camp, but just to give you a general overview, on our first day, we'll be showing up at Northeast Library at 1 p.m. So if you guys arrive, I think everyone's getting in on Monday. Some people later than others, but you'll have time to just kind of sleep in and relax for the morning, and then we'll jump in. And once again, I want to remind you guys, please do a 5-minute, be prepared to do a 5-minute presentation to introduce your library and to everyone, yourselves as well, but you know, you only have 5 minutes, so a PowerPoint is great, or a slideshow. We had one partner do a video, so no pressure, you don't have to do that, but that's an option, some sort of maybe performance art, I don't know, you know, it's up to you guys, but you have 5 minutes, so that's not that much. But we're going to be, you know, all getting to know each other that day. We're going to have a rep from Special Collections, from DCPL Special Collections, Lisa, who is behind me and who has been walking by every now and again. She's going to be there and talk a bit about programming. There she is. And talk a little bit about programming, because that's what she does. And then we're also going to have a representative from our labs department, the head of the labs will be there. And then we're going to be blessed, #blessed, with the presence of Lauren Algie, who is on the MemLab Network Advisory Board and used to work at DCPL and is basically the one that helped create the MemLab first, and then also helped write the grant to get the MemLab network started. So very excited that Lauren's going to be there. And then also we're going to get that first day will be a bit of housekeeping stuff about the hotel and meals being provided and things like that. But then you'll get a tour of our MemLab from Robert LaRose, who's the main librarian that works with the public and the MemLab and the people that come in for the appointments. And then also I'm very happy to report that we're having someone from the Frederick County Public Library, which is only about an hour away from here, from DC. And they're going to be bringing their mobile MemLab. They're not part of the MemLab network, but they created their own MemLab. Once we had ours up and had our documentation online, they got a grant and created a more mobile one. So Becca is going to be driving into DC from Frederick and bringing that along, so you guys will get to take a look at what a mobile lab looks like. And then also we're going to have visitors from Queens College Library, and they actually just got a grant to build a MemLab, so they haven't built a MemLab yet. But they're going to talk about how they got the grant, so that could be very helpful. And then they're going to have a lot of similar questions, I think, as you guys. And the rest of that day is going to be like a visioning quest kind of thing, more of like a brainstorming, goal setting time. So, but it's going to be I really wanted to give you guys the morning, but it's very much going to be a full afternoon. And then that evening we are providing well, not us, but the DCPL Library Foundation is providing a reception that we just got confirmed for where that's going to be. So I'll put that in the guide that I sent out on Slack. And so that's going to be that evening where we will have food, so dinner and drinks provided for you guys, where we can all just hang out and like not talk about video signals. We can if we want, but I probably won't. The next day we start off at our Northeast Library, which that's our home base, right? And then and we'll be doing a lot of hands-on stuff. And then we'll be going to Smithsonian National Museum of African American History that afternoon. And so we'll get a tour from the Media Conservation Lab folks, but then you guys will have the rest of the afternoon, at least an hour. I'm hoping more, but at least an hour or an hour and a half. I think the museum closes at 5:30 to check out the museum. So then Thursday, we start out at Northeast and do a lot of hands-on stuff. And then we go over to the Library of Congress, to their Madison building, and we get a tour from their preservation unit. And then we go from there to their manuscripts department and get a tour from them. So, and then the rest of the day is yours. That'll probably be an earlier day. And then our last day is Friday, which is just a half day, and we're starting in the morning at 9. And this is really where we're going to get more into the project planning and like strategizing, and you guys coming up with answers to questions. Okay, so like our first half day will be coming up probably with a lot more of like where we want to go, but then also the questions that we want answered. And then hopefully by Friday we'll be able to answer a lot of them, or at least be like, okay, I know write down who you need to ask to get this answered when you get back home. So then we're going to close out the day with talking about programming and classes. And I'll talk a bit more about like what preservation classes you can teach, how we teach all of it and how we sustain it, and how to teach these preservation, literacy skills to your public. There are a few other activities we can throw out there that you guys can bring to your public. We're going to have someone from within DCPL who has taught these classes as like a professional development. And so she was trained and then taught them. And so she's going to be there and be able to answer some questions from that viewpoint of a indirect librarian staff member. And then, just kind of answering additional questions, but we should be done by 1, if not sooner, on Friday. So you guys can have the rest of the day to yourself to explore DC if you're staying, or if you're flying out that day. We made sure we had plenty of time for people to get to the airport. So yes, any questions about the logistics of boot camp? Okay, we start at 1 p.m. on Monday or Tuesday. Tuesday, yes. Monday is a travel day, and also our libraries are closed that day because it's MLK Day. So 1 p.m. on Tuesday. And so everyone will be checking into their hotels on Monday. Any other questions? Once again, I am always available on Slack. Or if it's an emergency, please just email me directly. But if it's something you feel like everyone will, learn from the answer, please post it in Slack. Okay, hotel check-in when we get there. Paid in advance. Yes, it is. They have your names, so they'll ask for your ID, and I believe they will ask for a credit card for incidentals, but they will not be charging you as long as you don't order a bunch of room service or anything. You won't be charged on that card. It's just for incidentals. But yes, paid in advance as of this week. And there should be a catered lunch somewhere in there on one of our 2 full days, once again from the Library Foundation, but I haven't gotten the absolute okay on that and like which day that will be. Yeah. Maybe rethink your room service dreams. Yeah, I don't think the Holiday Inn has exactly stellar cuisine, but who knows? This is DC. But it does look like a nice hotel, not to say that. And I am also trying, just FYI, if you looked at the guide when I first immediately sent it out, I accidentally was looking at everything at the address in Southeast when the address is actually Southwest. And that matters here. So I don't live in DC, that was a real noob error, but I've fixed it now. So I'm getting locals to tell me recommendations of places to eat and hang out, because don't trust me for that. But if you ever go to Baltimore, then you can ask me. Okay. So yes, once again, I am going today's Friday, right? So next week's very full, getting ready for you guys, but I promise by Wednesday, I will have the video up for this and the slides up, so that you can take a look again, and maybe sort of digest a little bit more later. If there's anything in particular that you have questions about too, you can always ask. And the hotel, right, the hotel is the Holiday Inn, I think it's just Capitol, DC Capitol. It's, I remember the address, 550 C Street Southwest. So on Slack, I did put a link to the guide. So it's basically like a travel guide, and it has the official hotel name. Yes, thank you, Jonathan. Holiday Inn, Washington Capitol, 550 C Street Southwest. And so it's kind of right in the middle of things with the mall and everything. So it'll be, it's a bit of a walk to lots of things, but I think it's relatively convenient for all the places that we're going to be going. Oh, Brandon's been researching restaurants. Please share maybe in the random channel of Slack. Yeah, any Yelpers out there or anything. Yes, it is a couple blocks from the mall. Yes, exactly. So that will be a key place to do some touristy things. And don't forget our, the Smithsonian, at least majority of the museums here are free. Behind Air and Space Museum, yeah. So, yeah. Just let me know. I am looking forward to meeting you all and getting to know you better, getting to know your libraries better, and yeah, and just like showing you the good news of audio video digitization and memory labs. We're gonna have a lot of fun, and yeah, so safe travels to everybody. Have a great weekend, and please don't hesitate to send me any other follow-up questions about anything. Thank you. 3 minutes early. Yes. Okay. All right, everybody. Take care.